number one was the escalator one that you guys didn't like, a lot of you didn't like last year. But it's also an in and out problem. Remember, Californians should be good at these. It's an in and out problem in that you have people going into a line and keep people coming out of the line. Oh, right, you can put it right here. I know it was a little weird, but people were getting into the line and people were getting out of the line onto the escalator. So the in is right here, the rate in, and then the out is the 0.7 persons per second. If you did 0.7 t, that's actually how many people. Because you could say like after 5 seconds, 10 seconds, 20 seconds. So the rate itself for out is 0.7. The rate for in is the piecewise function. And they give you an initial condition, right? 20 people in line at time t equals 0. What part were you curious on, Betty?
So for number for b,
Yeah.
I wrote that I would do r prime of 300. Is that right?
Why?
Okay, because then I put that in my calculator. I got to roll and remember.
Yeah. Because think about who R is. R is the rate at which people are getting into the line. So it's how fast.
You need like the original.
Yeah.
Oh, so you do integration by next year?
Yes.
Okay.
Because you know how fast
Yeah.
and you know how many to begin with. But careful, would you have done RT minus 0.7? Because they're saying how many people are not entering, but in
Yeah.
line. Does that make sense? So this is how fast people are getting into line, and this is how fast people are leaving the line to get on the escalator. So you need both of the in minus the out to be the number currently there.
So when do you consider the 0.7, like when you're doing an equation?
R is how fast people are going into the line. 0.7 is how fast people are leaving the line.
Okay, so it's kind of like
People
the
into a
silo
park,
one,
out
when
of
it
the
was
park.
like WT minus GT.
Grain being added and then grains for them. Yeah, exactly. Does that make sense?
Yeah. And then how do you find when there's no people in the? Is that when RT equals 0.7?
When RT equals 0.7, which would be a critical number, it would be a 0 of the derivative. That's just when the rate that's not when there are no people in the line. That's when the rate of change of the line is 0. It's where the people coming in and people going out are equal. But that doesn't mean all the people have left the line. In letter B, you just made an expression, integration is net change, to figure out how many people are in line, right?
Yeah.
So if you were doing it between 0 to 300, right? Yeah, 0 to 300. Eventually, like in a mall or somewhere else, for one reason or another, the line's going to end, right?
Yeah.
So the people in line at T is equal to the people that started the line, and then how many people have entered the line, with how fast they're entering minus how fast they're leaving.
Yeah.
This is we don't know the time, that's the whole point we're trying to solve for, but they're saying, when will it be 0? So what you can do is you can go ahead and move your initial and say, when will the overall number of people in the line be negative 20? To cancel out the 20 that were already there with all of the going in and going out. I mean, that's the math of it, but the long story short is that you're taking the expression for the number of people in the line setting it equal to 0. At which place, this is a calculator problem?
Yeah. So do you graph it?
Ooh, greater than 300. I didn't even see it, that's my bad. If it's greater than 300, ready? P of T is going to equal P of 0. How many people started in the line? P from 0 to 3, sorry, not P, but 0 to 300 of R of T, which you would have already found, right?
Yeah.
And then people aren't allowed to get in line anymore. So then it's just, what do you want to do, plus and then negative 0.7, or what do you want to do, 0? Minus 0.7. Because we can't anti-derive that by hand, but we don't need to. It was used from 0 to 300 to figure out how many people entered the line, left the line. Where's the line at 300? And then from every point on after that, there are no more people entering the line. I just need to figure out, okay, how many people are in line at 300? Cool. When will, right? You see it?
Yeah.
When will they all have been on it? And this one I can do by hand. So I'd have my 0.7t minus that times 300. All right.
Could you do 2, B, and C? Because A and D are really easy, but B and C are really overwhelming.
And 2 is another calculator one. Researchers, plankton, cells per cubic meter. So in some sense it's rate, but they call it density. Yeah.
B is just like so much information. Just like,
Consider a vertical column of water in the sea with horizontal cross sections. Constant area. Okay. In my mind, this is a situation that we've never seen before. True? The AP can always throw plankton in a sea and a vertical column of water. What the crap? But, pause. If they're asking us to figure out how many plankton cells are in this column of water, and if plankton cells are modeled by millions of cells per volume, you see it? Per cubic meter. I need to, just thinking about math, I need to go ahead and multiply by a volume in order to get my millions of cells. I need to multiply by meters cubed, right? Just dimensional analysis. So therefore, why are they talking about cross sections?
it's volume.
So I'm going back to the good old-fashioned volume is equal to, okay, hold on. Horizontal cross sections have a depth of D is H height.
Yeah.
Whatever this is, whatever the area is, and it's not circular, it's some sort of weird, I don't even know what, but whatever this is, it would be a dy, but they say that depth is H. So I could be like, okay, fine, dH. I need an area formula in terms of H to throw into my volume, right? Volume by cross sections, I need an area formula. In between 0 and 30, they give me my bounds. If I can find that volume, I can multiply it by P. Let me just solve the density of plankton.
My question is, don't they give you a volume? Okay.
Yeah, so we could just make this from 0 to 30 because my area is constantly 3 square meters. Right? And that would give me my volume.
I think so.
It's kind of like a cylinder. I mean, it's awkward, and it is a column, which kind of makes sense. But you know how volume is area of the base times the height? So I need my 0 to 30 in order to be my height, but then they tell me what's going on for each and every sliver along the way. So as far as the area, I would have plugged in 3 for my area, square meters. Integrating that would get me cubic meters. Cubic meters, I would like density or like accumulation. We saw one yesterday with money. That was the one, James, that I was talking about with you and Maggie. We would need to, sorry, going back to P of H. Density of plankton and millions of cells per cubic meter. Should we have that? Let me get that P of H in here.
Well, isn't that-
Natural inclination.
For the millions of cells of the meters, because that would be H, you integrate pH.
I don't think you can integrate to get that though. It's not just who P of H is.
Oh, I guess so.
My thought would be, like, just from the math, I'm like, I'm going to plug into, so I think I would have done 0 to 30 at P of H, but in my mind, the units don't match up if I do that.
Wait, was this last 2 seconds?
Yeah.
This is dead.
Well, its volume is the integral of area. Like that wasn't too bad with cross sections. You need to multiply the volume by the P of H to get the millions of cells. I'm just trying to figure out, is it P of a constant or is it the integral from 0 to 30?
What are the answers?
Oh yeah. Guys, 2018. Oh yeah, they just multiplied.
Oh, okay.
3 times P of H.
So the pH is in Y then?
Right? Because 3 would be centimeters squared. Oh, I'm trying to deal with units. Sorry, limit properties. That's my bad. Integration, there is no like integrate one times integrate the other in the units. I was trying to do dimensional analysis illegally. My bad. So that would be millions of cells per cubic centimeters. That would be square centimeters, which you would cancel the square centimeters with the cubic centimeters. It'd be millions of cells per centimeter, and 0 to 30 would cancel out per centimeter. You would get millions of cells. By dimensional analysis was illegal.
So integration can cancel out the meters?
Integration always multiplies by 1 unit of the denominator. Feet per second to second, feet per second squared to feet per second.
Okay, because I was confused with like if integration only gets rid of time or if it could get rid of meters. But it can,
It can get rid of whatever with respect to
Okay,
because
gotcha.
my GH is meters.
Right. Okay, cool.
What would have been a lot easier though is to think of per area, cross-sectional slice, the density times that area accumulated through the 30. You can make your own formula without having to think of it separately. But dimensional analysis works.
Yeah, because the way you were doing it, because that would have made the first one just be meters, and the second one would have become millions per meter, and then
See
they
it?
would have
And then
canceled.
it would have, yeah.
Oh, okay.
Yeah. Our dimensional analysis. Guys, I'm sure you can find YouTube videos of people explaining 2018 FRQs if we need some extra. But remember, just bonus work, whatever you need to do Monday, and we'll chat. Otherwise, Tuesday, if you guys have AP Bio, you know what to do. Come early for the AP 7:30 all breakfast, yeah?
Oh, yes!
Yes. Bye.
We know she'll I know. As long as schools are super good.
We'll be here Monday.
Thank you.
What, really? Or something? What'd you say?
Yes, I wrote it, but
She's gonna have fun, I think.
Caution.
there you go. That's what this is.
There's like 4 that I didn't answer because I didn't figure them out. Should I just turn them in now? Or,
I would say, yeah. Do you have time to ask me one of them?
well,
Just for sake of your person, or you can ask me Monday if you don't
okay,
mind.
yeah.
But yeah,
That's a
turn it in.
lot.
You'll get it.
Okay.
Then that gives you time this weekend to work on other stuff, and then you come back Monday after. But yeah, you'll get it. I frankly don't have time to like check every single one, but I do check each section that you've got corrections in.
Okay. Yeah. I did it on freshman paper. It's okay.
Amazing. You didn't need to do that.
Okay.
So you get that turned in.
Ooh.